Hello students, what's up? Today we are going to take this example of finding ordered pairs when the equation is in this form. That is, all are in terms of 2 basically. So 2 raised to power a plus 2 raised to power 2b, we can write 4 as 2 square, and 8 as 2 cube, c is equal to 328. Now we don't know which one of the following is smaller, whether a 2b or 2 3c. So what we do, we consider a comma 2b comma 3c equals to we equate it with the pqr or xy, whatever you want, pqr, right? So you need to understand that I'm not equating a is equal to p. We are not equating a equal to p. We are just telling this 3 can be equal to this 3. A can be equal to P, can be equal to Q, or can be equal to R. So please make a note of it. So anyone can be equal to anyone, right? And so we are substituting, to the equation will become 2 raised to power P, 2 raised to power Q, 2 raised to power R, right? From where a can be p or 2b can be p, so we can write 2 raised to power p, right, is equal to 328. That it is quite obvious that someone will less than someone and someone will less than someone. So let p is less than q and q is less than r. So we can take 2 raised to power p as common. So we will get 1 here, and we will get 2 raised to power q upon 2 raised to power p plus 2 raised to power r upon 2 raised to power p equals to 328. Now 2 raised to power p, 1 plus 2 raised to power q minus p plus 2 raised to power r minus p equals to 328 can be written as 8 into 41, right? Now so this 8 is nothing but 2 cube, and this 41. So we can say that p should equal to 3, and simultaneously 1 plus 2 raised to power q minus p plus 2 raised to power r minus p should equals to 41. Because this is the multiple of 2, this should get equated to this. Now as we get p equal to 3, we have considered p as smallest here, so we get the smallest term equal to 3 basically. Q also can be equal to 3 also. If we change that q is less than p and less than r, q is the smallest then. Now 2 raised to power q minus p plus 2 raised to power r minus p is equal to 41. So we can see that q minus p and r minus p, r minus p and q minus p, which one is smallest? We can see that q minus p is lesser, right, than r minus p, because r is greater than q, and we have subtracted p from both sides. So we can take the smaller one, that is q minus p, 2 raised to power q minus p as common here. So we will get 2 raised to power r minus p upon 2 raised to power q minus p equals to 41. Now 2 raised to power q minus p, 1 plus 2 raised to power minus p 2 raised to power r minus q. Now 41, how can we split 41 in terms of 2 multiple of 2? So we can do that, right? We cannot we cannot factorize in terms of 2 here, right? So what to do in this case then? So this issue had come because we have forgotten 1 here, right? 1 plus, so 41 can be written as 1 plus 40, and this one will get cancelled. This is 40 over. Now this can be written as the multiple of 2, 8 into 5. So nothing but 2 cube into 5. So we can say that q minus p is equal to 3 again by comparing this term to this, and 1 plus 2 raised to power r minus q equals to 5. 2 raised to power r minus q equals to 4, which is 2 square. We get q minus p equal to 3, and from here we get r minus q equals to 2, and we had p is equal to 3, so we get q equal to 6, and we get from here r equals to 8. So we get value of p, r and q, p, q, r basically, right? So we have equated this term here. Now we can take the values a, 2b, 3c. As we can see that it is this is the multiple of 3, then this can be equated to 6 or 3, because PQR can be equal to 3C also, right? 3C can be equal to P or Q or R, but it cannot be equal to R, so we can equal 3C to 6 or 3, right? When we equate 3C to 6, then 2B will become one of this or this. So as we can see that the 2B cannot be equal to 3, so we have to equate A with 3 here, and 2B to equate with 8. If 3C is equal to 3, then we have to equate, now this is gone here, we have remaining this 2. This can be equal to 8, this can be equal to 6. Similarly, 3C is equated to 3, then 2B can also be equated to 6 also, because it's a multiple of 2, and this can be equated to 8. I think there are no more possibilities. 3C is equated to 6, and this have only one option, right? And 3C can be equal to 3, they have two options, that's it. So we can see that A can take value 3, 6 or 8. For the same, B will take value 4, 2B is equated to 8, then B will be equal to 4, and C will be equated to 2. Similarly, A will take 6, then B will equal to 4 again, and this will be equal to 1, and C, this is equal to 1, then B will be equal to B, C will be become C. If A is equal to 6, then B is equal to 4, and C is equal to 1, then A is equal to 8, then B will become 3, and C will become 1. And when A is equated to 3, B will become 4, and C will become 2. Correct? Sorry, C will become 1. Sorry. So please recheck it. I am getting a bit confused. But the method was quite simple. You have to consider one of them smaller and equate to some other variables and take out common and find out the multiple of 2 every time, and you will get the answer. Thank you.